Today we're going to discuss graphing rational functions. Now, a rational function is any function that can be expressed as a fraction. In other words, with a numerator and a denominator such that the numerator could be a constant, it could be a polynomial, and the denominator could be also a constant or a polynomial. And here's an example. We have f of x is equal to x minus 2 over x plus 1 and x minus 4. And this is the graph that's associated with that. We're going to learn how to graph these without a calculator. Now you'll notice a couple of things here. We have these dotted vertical and a dotted horizontal line. Don't know whether you can see that or not. But the dotted vertical lines are called vertical asymptotes, and they describe where the function is undefined. And if you notice, they're at x equals 4 and x equals negative 1. Those directly relate to part of the function. And if you look here, I have x minus 4 and x plus 1. So it has to deal somehow with the denominator of the function. In fact, we know that in any fraction, if the denominator is 0, it's undefined. And so if x is equal to negative 1, this term goes to 0, thus making the denominator 0 and the fraction undefined. Likewise, if x is equal to 4, this term goes to 0, the denominator goes to 0, and the function goes undefined. Now, this horizontal asymptote coming across here at 0 basically talks about what happens to the graph when x is very negative and very positive. So what we're really talking about is the end behavior of the graph. As x gets very, very big positively, we see that the graph is approaching that line. As x gets very, very big negatively, we see that the graph also is approaching that line. It doesn't talk about what the graph does in the middle, just at very, very large and very, very small. So let's talk about some rules for graphing these rational functions. And there's a bunch. You got to follow these steps. The first thing that I would do is find the intercepts. So like in any function, we set x equal to 0 to find the y-intercept and y equal to 0 to find the x-intercept. In order to find the vertical asymptotes, we set the denominator equal to 0 and solve, and those will give us those vertical asymptotes. For the horizontal asymptotes, there is a process of 3 items you need to look at to determine what the equation of that horizontal line is. If the degree or the greatest power of the numerator is less than the degree of the denominator, that horizontal asymptote is equal to 0. If the degree of the numerator equals the degree of the denominator, then the horizontal asymptote has an equation of y equals the division of the two leading coefficients. Lastly, if the degree of the numerator is equal to the degree of the denominator plus 1, then you won't have a horizontal asymptote, you'll have a slant, or as our book uses, oblique asymptote. And you use long division to find that out. We'll tackle this concept tomorrow. And then you sketch a graph using everything that you've got. And finally, if you need some extra points, you plug them in to see how to complete it. And let's do some examples. So in this example, we have a constant on top. We have a binomial on the bottom. I'm going to first start by finding my intercepts. So we set x equal to 0. Find my y-intercept. In doing so, I get y equals 3 over 0 plus 5 or 3/5. So 0 and 3/5 is a point on the graph. Second, we'll set y equal to 0 and solve for x. So if y equals 0, I have 3 over x plus 5. I multiply both sides by x plus 5 to get that off the bottom. You'll notice on top, the x plus 5 reduces. 0 times anything is 0. We get an untrue statement, therefore no x-intercept is going to exist. So right now, if I wanted to start graphing, I could take and draw a y-intercept at 3/5, which is just a little bit above that axis, and no x-intercept. Next thing we're going to do is calculate a vertical asymptote. And to do that, we stated we're going to set our denominator equal to 0. So our denominator is x plus 5, set that equal to 0. X equals negative 5 is my vertical asymptote. And if you think about it, when x equals negative 5, denominator is equal to 0, thus the whole fraction is undefined. So at negative 5, 1, 2, 3, 4, 5, I have this vertical asymptote, which is a line the graph will not cross. Now for the horizontal asymptote, we were supposed to go through, got to spell that right first of all, we're supposed to go through a couple of different setups. For the horizontal asymptote, we check a few items. First, we see if the degree of the numerator is less than the degree of the denominator. Well, let's take a look at that. My degree in my denominator is 1. There is no x term here, but there actually is. It's x to the 0 power. Anything to the 0 power is 1. So indeed, my degree of the numerator is less than the degree of the denominator. Therefore, the horizontal asymptote is y equals 0. So I'll draw a horizontal line going through this axis. Now again, what this states is it states that as x gets very large positively, y gets close to 0. It's like an end behavior. And as x gets very, very large negatively, y gets close to 0. Now, knowing what I know, I can draw the right side of this graph because I know it's going to go through this point, and I can't pass this horizontal axis because I haven't calculated any x-intercepts, and there's not going to be any. So what I do is I go through that point and approach that line and go up. Again, I can't go down because it would cross the axis. As x gets very large, y gets close to 0. So I do this. Now, unfortunately, I don't know whether the rest of the graph is up here or down here, but I do know it's not going to cross this line, not because it's an asymptote, but because there are no more x-intercepts. In fact, there are no x-intercepts at all, so it's not going to cross that horizontal line. So what I'm going to do is I'm going to plug in a point. I'm going to pick the point f of negative 6 and see what kind of value I get out. And again, I'm plugging into my original equation, which is 3 over x plus 5. So in doing so, I have the following. I have a positive from the 3. Let's go up to negative 6. And then on the bottom, I have a negative, because negative 6 plus 5 is a negative. This ends up being a negative value. Therefore, at negative 6, which is right around here, I have a negative value. As I move closer to this asymptote, I'll keep approaching a negative. And then as I get further and further negative, I get closer and closer to y equals 0. So that's a graph of the function. If you go through step by step, it shouldn't be too bad. We've got a ton more examples, so let's get started. Again, I'm going to go through and find my intercepts, set x equal to 0. In doing so, y equals 0 over 2 times 0 minus 4, or 0. So I have a y-intercept equal to 0. Now I'm going to set y equal to 0 to find my x-intercept. Multiply by 2x minus 4 to each side. You'll notice the 2x minus 4 is reduced, leaving me with an x. 0 times anything is 0, so x equals 0 is my x-intercept. And that makes a lot of sense because if I draw my coordinate graph and I put a y-intercept at 0, well, my x-intercept is 0 at that point as well. Next, we'll set our denominator equal to 0 to find my vertical asymptote. And in doing so, I have 2x minus 4 is equal to 0. Therefore, x is equal to 2. And that's my vertical asymptote. To find that horizontal asymptote, I look at the degree of the polynomial in both the numerator and denominator. You'll see here the degree is 1 and the degree here is 1. And in that second rule, it says if the degree of the numerator equals the degree of the denominator, divide the coefficients. Well, the coefficient in this numerator is 1, and the coefficient of the degree term in the denominator is 2. So y equals 1/2 is my horizontal asymptote. So let's see what this graph is going to look like with this information in it to this point. So now I'll go up to 1, draw a horizontal asymptote at 1/2. Again, I know for a fact that as I get bigger in the negative direction, my graph is going to approach this horizontal line. So I'm going to draw my graph like this. Now what I don't know is if this is going to come up in this direction or down in this direction. I do know, however, what this other side is most likely going to look like. I know it's going to approach this line. It's not going to go through this axis, so it's not going to cut down in this direction. It's got to go up, and the reason why I can say that is my only x-intercept is 0. There are none here. So I know it's going to approach up this way since it can't cross that axis. And it has to approach this line, this horizontal asymptote, as x gets very large. So this side's got to look like this. So now I'm going to plug in a point to see what this graph looks like. I'm going to plug in f of, let's say, 1 and see what my graph looks like. F of 1 gets me a positive on top and a negative on bottom, which equals a negative. Therefore, this guy is going to go down this way. Let's take another one. So in this case, again, we're going to go through our steps. Set x equals to 0. Find out what y is. When x equals 0, y equals 0. Then I'm going to set y equal to 0 and find x. Therefore, 0 equals 3x squared over x squared minus 9. Multiply by x squared minus 9 to both sides. We get 3x squared equals 0. Therefore, x equals 0 again. So I take and graph the x and y intercept at 0, 0. We set our denominator equal to 0 to find our vertical asymptotes. This is a quadratic, so we're going to have to factor. It's x plus 3 and x minus 3, giving me values of 3 and negative 3 for x. This tells us we're going to have actually two vertical asymptotes. One going through 3, one going through negative 3. And for our horizontal asymptote, again, we notice that our degrees match. Therefore, our horizontal, I divide my coefficients of 3 and 1, and I get y equals 3. I go up 1, 2, 3, and draw a horizontal line across. This tells me what the graph approaches as x is very big and x is very small. Now you'll notice once again that I only have one intercept, so I know it's got to go through this point. On this side, it's not going to go through this axis, and it's not going to go through this axis over here because there are no intercepts there. Yet, the graph has to approach this line up here and this line up here as I get very big positive and negative. Therefore, I know that the very left has to look something like this, and the very right has to look something like this. I'm not so sure what the middle looks like. It could be going down in both directions. It could be going up like this. It could be coming down like this. You know, there's a whole bunch of options, so I've got to pick a couple of points. I'm going to, once again, use my equation, but the equation I'm going to use is a factored form of this equation, so I'm going to look at f of x equals 3x squared over x plus 3 and x minus 3, and I'm going to plug in f of, let's go 1, and f of negative 1. So when I plug in 1, you'll notice the top is positive. On the bottom, I get a positive and a negative, which is overall a negative value. So at 1, I get a negative value, which means it's got to go something like this. Now when I plug in a negative 1, you'll notice I get a negative 1 squared times a positive is also going to be a positive. And then on the bottom, I have a positive and a negative, which again is overall negative. So there's my graph. So in this example, we go through the same process. We set y equal to 0. Find our x-intercept. You'll notice in this case, like in all the others, if I multiply x squared plus 4x minus 5 to both sides, they reduce here. This side 0, so 0 is equal to x plus 7, and x equals negative 7 is my x-intercept. Y-intercept, set x equal to 0. We get y equals 0 plus 7 over 0 plus 0 minus 5, or negative 7/5. Vertical asymptote, set denominator equal to 0. It's a trinomial that's going to factor. So I get x plus 5, x minus 1, or x equals 1 and negative 5. Horizontal. In this case, we notice that the degree of the numerator is less than the degree of the denominator, therefore y is equal to 0. So let's take a look and see what we have. Again, these are sketches. They're not exact, but they're a pretty good eye of what we're actually going to see if we plug this into a calculator. So I have a vertical asymptote of 1 and at negative 5. I have a horizontal asymptote at 0. And again, we found that there's an x-intercept at negative 7. So here's negative 7, and we'll plot a point right here. Now, probably asking, well, hey, why is this crossing this asymptote? Remember again that the horizontal asymptote only describes end behavior, and negative 7 is nothing compared to negative infinity. Now, there's a couple other things we need to note. One is that this graph will only cross the axis in this one spot, and it's not going to cross over here, and it's not going to cross over here. Therefore, I kind of know what this middle term is going to look like. It can't cross this line and go up, so it's got to come down this way. And it can't come up here because, once again, there are no intercepts over here. So it's got to go down this way. I don't know what it's doing up here, down here, or up here, down here. I just know that it crosses. So I'm going to have to pick a series of points. In this case, I will once again pick, let's go f of 2, Over here, I should probably pick this point to see whether it's above or below and then see if it crosses. So if that's negative 5, I'll go f of negative 6. That was 7, and we'll go f of negative 8 to see what happens on that side. Again, I'm going to pick my factored form, so that's y equals x plus 7 over x plus 5 times x minus 4, because I find it's easier to just state whether it's positive or negative by using this factored form. And we'll start with f of 2, which gives me a positive over a positive and a positive, which is all positive. So since f of 2 gives me a positive value and it's not going to cross, my graph's got to look something like this. If I take f of negative 6, then I still have a positive on top, a negative and a negative on bottom, which equals, once again, positive. So over here, it's got to go this way. And then I need to know if it comes back up and then down or goes under and comes back up. It's got to do one of those. So I go f of negative 8, which gives me a negative in the top and 2 negatives on the bottom, which overall is a negative. So that means it's going to come down and then come back up to that line, because once again that horizontal asymptote describes end behavior. Let's do another. In this case, we set x equal to 0, find our y-intercept. So I have y equals 0 over 0 plus 1, or 0. Find my x-intercept. Again, set your y equal to 0. Multiply by x squared plus 1 to both sides, thus giving me 5x is equal to 0 and x equals 0. My vertical, I set my denominator equal to 0, so now I just have to know when x squared equals negative 1. That's never going to happen, so there are no vertical asymptotes. My horizontal, I look at my degrees, and once again I have a degree on top that's less than the degree on the bottom, therefore y's got to equal 0. So we go ahead, sketch out what we've got. I know this goes through the origin. I know I have a horizontal at y equals 0, and we just got done saying that's okay, because that horizontal is only going to describe end behavior. And we said we have a vertical at 0 as well. So now I have no idea what this graph's going to do. I need to pick a couple of points, so I'm going to go f of 1 and f of negative 1 to see what happens on either side. No matter what, though, I know that it's going to approach this asymptote as x gets very large and very small. Since this doesn't factor, I'm just going to plug right into that function. So 5x over x squared plus 1 is what I'll plug into, and I'll take f of 1, which gives me a positive over a positive, which equals a positive. So it's got to come up and back down, and then f of negative 1 is going to give me a negative over a positive, which is a negative. So this comes down and back up. So it's going to look something like this. So here's our last example. A little more involved. We'll take and go through once again, find our x-intercepts and y-intercepts. Y-intercepts at x equal to 0, we end up getting negative 36 over negative 2, or 18. Find our y-intercept, or our x-intercept, sorry, that was our y-intercept. Find our x-intercept, set y equal to 0. Therefore we have 3x squared minus 3x minus 36 is going to equal 0, because when I multiply the x squared plus 2x minus 2 to both sides, it goes away. I divide everything by 3, get x squared minus x minus 12, therefore x minus 4, x plus 3 equals 0. So 4 and negative 3 are my x-intercepts. Vertical asymptote, set that denominator equal to 0. End up with x plus 2, x minus 1. I have x equals negative 2 and 1. My horizontal, I have matching degrees, therefore y equals 3 is my horizontal. So once again, let's go ahead and sketch out what we know. I know I have a y-intercept way up at 18. Let's just call 18 up here. I have x-intercepts at 4 and negative 3. I have a horizontal at 3. And I have vertical asymptotes at negative 2 and a positive 1. And in this case, I'm in luck because I know exactly what this graph looks like. Here's what I know. I know it goes through these 2 points, doesn't go through a point in between here because I didn't calculate an x-intercept here, and it has to approach this horizontal line as I get very large. So I know it's got to go from here out. I also know it's got to go from here out. From the top, I know it can't go down because it would have to continue going down, so it's got to come up and up. The only thing I don't know is what happens here. Does it bounce off this axis and come back up? Because it certainly could. Likewise, it could come up here. My guess is they both go down, but I'm going to plug a point in just to check. And when I plug that point in, I'm going to use the factored form. So my factored form is going to be 3 times x minus 4, x plus 3, over x plus 2, x minus 1. It's going to be my y value, and I'm going to pick values of, let's go f2 and f of negative 2.5. So let's start with f2. From the 3, I have a positive, a negative here, and a positive, over a positive and a positive, which ends up being negative overall, just like I thought. When I plug in negative 2.5, I get a positive from the 3, negative for the next term, and a positive for that last term, over a negative and a negative. 3 negatives, 2 positives is always a negative. That goes down. So then I'm done. I know it was a long one, and it's kind of involved. Practice is going to make you better. So make sure you practice well. You can use your calculator to check your answers. Do your Connect Ed, fill out your lesson summary, and I'm sure we'll talk more tomorrow.